Меня зовут Вадим Осипов.
Hi everyone, my name is Vadim Osipov,
И со мной сегодня будет выступать Дима Русак.
and Dmitry Russak is going to is going to speak together with me. He is head of team lead engineering at Yandex.
Yandex Cloud.
Today we'll be discussing RCE.
Про то, что такое managed service, какие в нем есть проблемы.
In RCE vulnerabilities in Managed ClickHouse,
И, собственно, взгляд
the perspective of SOC Yandex Cloud.
что такое managed service,
We have already talked about
в частности, в прошлом
managed services and how it's arranged at Yandex Cloud. Last year, we made a presentation here on managed databases, but let me just remind everyone quickly about what it is and how it's structured. When a customer of a cloud provider would like to start using the managed service X, in fact, what they're getting is a couple of idea ports in their network and some identification data. If they would like to start using service managed Kubernetes, they get an IP address on their own network. The port is usually known, 443 or 6443. And then using VN token, they start sending a network request in Kubernetes master to control their cluster. It's clear that for this service to operate, somewhere a process should be running on an operating system or virtual machine. Most likely, next to it, other processes will be running to support the service. Maybe they will be running in containers, maybe not. Somewhere close by, there should be other similar processes running, ensuring the operation of the service for other customers, customers of similar managed services. Depending on the multi-tenant architecture, these processes can be launched on the same virtual machine, servicing different customers, maybe in different containers, or how it happens in Yandex Oblak on a different virtual machine. Every customer, in our case, every managed service gets its own VM, and the processes of a specific customer are placed into it, the managed services that pertain to a specific customer. Those VMs have two network interfaces, one looking at the customer's network for it to interact with its network, and the other one is the counterplay private IPA. What are the main problems? Why do we need security there? Well, since we start with a managed service process and other processes close by that correspond to other customers, then the attacker may try to steal the data of other customers because those customers are somewhere close to our managed service. And the second vector, if managed service is penetrated, then the attacker may try to attack the internal counterplane to which the attacker will gain access. An interesting fact here is that under certain conditions, these items are actually replaceable. That is to say, if the cloud provider uses their own service, like Yandex Cloud uses its own MDB service, then the abuser, having gained access to the customer databases, will also gain access to the database that pertains to the cloud provider and thus also breach the infrastructure of the cloud provider. Several disclaimers over here. The way we built our architecture is not to be afraid of RCE in managed services. Ours are virtual machines which run processes that correspond to managed services of different customers are trustless. We do not trust these VMs. But we do not want abuser to find the RCE to exploit it. We do not want to give more freedom to the abuser and increase their chances to exploiting the vulnerability. What are the main problems? The solution that underlies the managed service enables code execution out of the box. Many databases can be configured in such a way that via SQL interface system commands can be executed in the cloud. Something like this should be prohibited. That's why we install our patches. We bring our patches to support the role model of the cloud in these products, and the service becomes more complex necessarily. One other item is that another basis of managed service is usually some complex open source products. If those products get a vulnerability, a public vulnerability is identified, most likely there will be a time gap when people will be already aware of the vulnerability and maybe there is a POC to exploit it, but your service is not yet patched. So generally the vulnerabilities can be there, but you must know how to secure yourself against them, how to control them, and how to detect them. What do we use? First, we isolate the process at the level of the operating system. We use AppArmor. I'm going to talk about it a little bit later. We also use CComp to limit the number of system calls that the process may use. Then we also limit the capabilities of the process, and we also use containers. Although the process is isolated, we still want to know what happens there. That's why we have alerts, and we respond to them. We use Osquery as the main agent to collect the security metrics and logs. We also use services logs. We use audit trails, and we can also use many other different logs. It would be great to test these two items, process isolation, alerts, and response. And that's why we run red team exercises, which we do. And we also have a bug bounty program that motivates external researchers to look for vulnerabilities in our products and to let us know about them for a prize, for an award. And we also run audits of the security of our services and new features. AppArmor. Why AppArmor? It helped us to detect in real time that someone is exploiting an RCE vulnerability in our service. AppArmor is the security module in the Linux nucleus that uses the mandate model to differentiate between accesses. It's more complicated than the discrete access model that is generally used in Linux. And this is how it works. You install the AppArmor, you describe the app profile, you include all the information about what this app is allowed to do. Everything that's not in the profile automatically will be considered banned. That's the workflow. We have a process. It runs in user space. It communicates with the OS, and it makes some system calls. When the system call goes to the nucleus, it is first checked by this discrete access model that is implemented to Linux by default. After that, it gets to the LSM interface, and the LSM interface will readdress the decision to the AppArmor module. AppArmor will check against the active profiles database, and then it will decide whether this action can be continued or the action should be rejected. I should also say that AppArmor has two modes of operation. There is enforce, which means actually that everything that's in the profile will be banned, and the other mode is complain. It means that everything that's not described in the profile, all actions will be authorized, including the ones that are not described in the profile, but anything beyond the module, it will be logged. And an event will be generated. At Yandex Cloud, we use both modes. The profile for the ClickHouse, it helped us detect the exploitation of vulnerabilities. Here on the slide, you can see an example of a profile. If you take a look at the second line, you will understand that this profile will apply to the processes launched out of the ping binary file. Complaint means that the profile is running the complaint mode. All actions are authorized, nothing is banned, but everything that's not matching the profile, everything besides the profile, all the actions that are not described in the profile will be logged. What else can you limit using AppArmor? What can you limit using AppArmor? First and the most popular feature is access to files. If you look at the last line, it says that permission R .conf file in the etc folder. Well, of course, it means that the process is authorized to read this file. You can also limit the capabilities, the network, the inter-processor interaction, and it's not a complete list. And now to RCE. But before I go to RCE, there is something that I also need to mention. At ClickHouse, you can execute commands of the operating system. If you download ClickHouse on your laptop, you install it, you will be able to configure it so as to execute system commands using SQL interface. Of course, this is prohibited in the cloud. Another fact is RCE was detected by external researchers as a red team was making their investigation. Yes, we had the alerts, we realized that there is an exploit, we fixed this vulnerability quickly, we patched it, and now to the vulnerability itself. First thing you need to understand how the researchers exploited the RCE is that ClickHouse has the from URL function. You can do the asterisk from URL and send a network call. They used it to increase the privileges in the Managed ClickHouse. At Yandex Cloud, in this database, we have systemic privileged user, which is admin. And by default, the customers cannot use that particular username in the database. But a mistake was made, and from the local host, you could connect using this name without the password. And this is what the researchers did using the URL function. They send an HTTP request to the local host, HTTP interface of the ClickHouse. They send the name of the user and an empty password field, and they send a request on behalf of a system privileged user, and this is how they increase their own privileges. That's how they raise them. Another fact, in the Managed ClickHouse service from Yandex Cloud, when you generate or change your instance in the database, will limit the set of configurations that you will be able to change. But the researchers found an XML injection now IP, and they configured the options that shouldn't have been configured, that are banned. The first option they used is user file path. What does it? What is this function about? If in ClickHouse you have the right to communicate with the file systems, like to write or to read files, then you will be limited by this line. You will not be able to go beyond the value of this box. But they installed it into the root, and this is how they could communicate with the root. And another one is user-defined executable functions config. What does it mean? It means that the path in this parameter, will be read by ClickHouse, and they will be transformed into user-defined functions, UDF. This is the way for system commands to be executed in ClickHouse. So the chain looked as follows. They increased their privileges to systemic privileged user admin, which enabled them to write files into the file system. They wrote user file / and then they could read and write files from the root. After that, they created a file in TMP, and the content is shown here in the left topmost corner. It's a XML file with a UDF function. It's executable, exec ID, and cut by bash is the command to be executed. They replace the parameters and they wrote the DMP category. The system read the file and it created an executable function that could be used to execute the commands of the operating system. Over here you can see parts of the history of the SQL request coming from their instance. They did select, exec it, and after that ID, PS, etc., etc. Now I'd like to invite Dima to the stage.
Так. Раз.
Testing. Hopefully
Так, всем привет.
you can hear me. Hi everyone, my name is Dim. I'm going to tell you about how, from the technology and process point of view, we investigated this incident.
Следующий слайд.
Next slide.
Для того, чтобы нативно собирать события
To natively collect the events in AppArmor, we use SQL. Vadim has already described how AppArmor operates, and now I'm going to tell you how we collect the incidents and how we analyze them. In order to collect the events in AppArmor, we use Osquery. We executed a table that's called AppArmor events. You are looking now at an abstract from the slide. These are some of the fields that we are collecting: the message from AppArmor, the profile name, and several other fields that allow us to investigate what happened on the host.
Далее нам недостаточно понимать.
It's not enough to understand
Пришло сообщение AppArmor
that we received a message from AppArmor. We also need to understand where the host is located in order to investigate the incident and to do more profound intelligence and to integrate our alerts into our workflow. And for this, we generated another table. It's called Your Cloud Instance Metadata. It lets us understand in which folder in which cloud this or that host is located. Basically, the idea of this table is as follows. It collects metadata from the Yandex Cloud, and it adds this info into Osquery table. The resulting event looks as follows. Here you can see the first part, everything that's related to the AppArmor fields, and after that we add to every event information about the instance and its coordinates, the folder ID, cloud ID, and other parameters. On the slide you can see a pipeline that we use to gather events from Osquery. Osquery subscribes to audit of AppArmor events, and it generates an event that was shown on the previous slide. After that, the events using HTTPS are sent to the Osquery center. We wrote the center ourselves, but you can also use a vector or something else. What it does, it splits the Osquery events, because by default they are sent by patch. Well, actually, in the latest version of Osquery, you can also send your events by event, and then depending on the type of event, it sends them to different storages. It can be a ClickHouse, or you can be your own CM system. Why is this necessary? For the CM system to receive only the events that are used for alerting and basic investigation of the incidents, and the cheap data house can be used to keep data on process execution or something else, the heavier ones. As a result, we get an alert that looks like this. I'll tell you a little bit more about it and how we analyze it. How we parse it. This requires collaboration between SOC and the incident response teams, and also the team that supports and develops the server, because AppArmor applies to all services in Yandex Cloud. This incident first goes to SOC analysts. They do basic triage. They will see whether it's true or false positive, and then they will upgrade the alert, or they will close it, or they will escalate it. Here, ClickHouse sends batches. This is something that it's something that should not happen, because this was one function that was disabled by us on purpose. we called in the service team that's responsible for the host and the incident response team. The alert was escalated into an incident and the investigation took place. I wanted to say thank you to the teams that support their services because they help us very much during investigations. So thank you very much, guys. Let me explain this. What you saw on the previous slide, we see that the ClickHouse process starts with bash and then another bash and then ID is executed. So this got us worried. The first process, the ClickHouse one, is the one that runs in the ClickHouse cluster. The second bash is needed to launch the UDF function that Vadim talked about. The third bash is what happened inside this function card bash. And the ID is the command that was sent to the input of this function. If you noticed on Vadim's slides, there was exec ID and in brackets there was a parameter that was sent, so that's the parameter. Then during investigation, the analysts reconstructed the actions on the host. They found the standard commands associated with reconnaissance, and we also found another interesting line. You see it now on the slide. There was an attempt to call the system account of Yandex Cloud. It means that probably that if the attackers hacked, well, not attackers, actually researchers, if they hacked it, then they can use it further to investigate the cloud provider infrastructure, get stuck on this infrastructure, and then manipulate it. We also found this record in the ClickHouse events. This is what we have. We've got RCE, the reconnaissance commands, and attempts to query the secret of the system account. Then we split into several tracks. The first one analyzed what happened on the host. We collected temps, whatnot. We did basic analysis. The second track investigated the chain on the service, together with the ClickHouse team that supports and develops the service. And the third track was to make sure whether the secret was lost. If it did not leak, then which actions took place in the cloud, and what the researcher did or did not do in the cloud. So what can help us in the process? A couple of words about audit trail. What is audit trail? In fact, audit trail is the service that is used to collect and download the audit events related to the resources of the cloud. This service is integrated with most of the Yandex Cloud services, and it collects control plane and data plane events. Control plane events are the events related to the changes and the level of management. For instance, a VM was generated in the compute service, or data plane events, for instance, is like there was a call to the secret logbox. And so it's an event related to the operation of the service itself. Next. Too fast. Too fast. Audit trail will help us answer the following questions. Who generated the resource, or how the resource was changed? Where did the user or the service account come from? If we talk about the control plane events, or in the data plane events, we will be able to answer the following questions. Who called the secrets? Which changes took place in databases, object storage? Who called the object storage object? Or which request came to DNS? Which queries? Right. Audit trail can log many things, and this list keeps expanding, and it helps us analyze what happens in our cloud. This is what an event consists of. It consists of several blocks. First block is information about the subject, who performed this or that action. It can be a service account, a regular user, or a federated user. So subject ID, subject name, subject type show us the identifiers of the subject. After that, you see another block, details. It depends on the service. In fact, it's information about the object that was manipulated one way or another. For instance, a Managed ClickHouse cluster was created, or a virtual machine, or not created, or an error took place. The third block is metadata, the type of the request, the source of the user, of the service account, which user agent was used, and the ID of the query. And the last block tells us about where this or that resource is located, the object with which an action took place, which organization, which cloud, and which folder. Next slide. Here on the slide you can see a workflow of how we collect the audit trail in the SOC. Audit trail natively sends the data into Yandex data streams. They are message brokers, basically. Our consumers, after that, read the streams for events, and they send them to cold storage for long-term storage or into CM system to generate responses and alerts. If you do not have a CM, you can also use a native pipeline. Trail events can be sent to object storage or data streams, and you can query them via Yandex Query. Yandex Query is the SQL-like query language. What we would like to test, to make sure that there was no malicious activity, we need to understand where the user came from, which resources were involved, and we can generate the following query. We filter the subject by subject ID and by the fields like the address, subject ID, subject name, the cloud name, event type, user agent, and additional details about the event. After we have generated this table, you can use it to conduct analysis, like please find me all unique IP addresses for the service account, what its remote addresses were, or please find me all the unique user agents for this user account. So you can play with the requests, with the queries, and you can generate something like this, like please find me all types of the events from the service accounts that were generated from a particular IP. During investigation, generating queries is all very well, but it would be best if we could identify suspicious activity instantly or almost instantly. An audit trail does the job. All alerts can be split into two parts. There is the CSPM alerts. They are the alerts that will help you prevent an attack in the future, like you open the buckets to the outside, or IP cubers. They have a wide IP facing the outside of your perimeter, and you're like, oh well. And the second type of alerts is identifying threats, detecting them. You can use audit trails to cover many tactics and even techniques, or you can generate your custom rules. Here you can see 3 alerts that we implemented. They are just examples. In fact, of course, we have more than 3, but this will give you an idea of how audit trail can be used. The first alert tells us that there was a query to the resources of the cloud from the external network on behalf of a service account. According to our policies, authorization keys cannot be issued, and we also control for service accounts not to do that, basically. We know how to collect all our IP addresses. We can differentiate between ours and not ours. We wrap that into lookup, and then joined with audit trail data, we can generate this kind of event. The other alert is more CSPM kind. This is a resource with greater authorization, greater access rights. What does it mean? For instance, S3 bucket is closed, it's not public, but the whole of your organization has access to this S3 bucket. You have 10,000 employees, and they can all look into S3 bucket. We don't want something like this to happen. We want to control for it. So this is yet another alert. And the other alert shown here is more of statistical nature. we detect no anomalous number of logbox queries.
По обращениям к секретам per сервисный аккаунт, плюс добираем туда какую-то метаинформацию.
And then we look at peer service accounts, we calculate percentiles, we calculate the 50th percentile, the median, and then we calculate the standard deviation to find an anomaly. And so what have we been able to find? Nothing.
Исследование активности по аудит-трейлу. На самом деле это связано с тем,
But that's only as part of reviewing the activity
анализе хостовой части, то, что
in the audit trail.
Исследователи получили RCE, не имел прав на чтение.
So it turned out that the user did not have the rights to read
Как говорится,
a particular point of data.
спасибо всем большое за внимание.
Thank you very much for your attention.
Подождите. Минутка рекламы.
Wait a moment, please,
Первое.
for a small moment of advertising. First, you're welcome to participate in our bug bounty program. Yandex and Yandex Cloud pay money for finding issues and bugs. And you're also welcome to join our community.
Розыгрыш футболочек.
Please scan the QR code, and as far as I know, there is a contest to win Yandex and Yandex Cloud T-shirts. But that's I'm not certain about that, so please check it first. Okay, and with that, thank you.
Так, вопросы?
Questions?
Пароль, что ли? Это старый.
Ну, значит, всем все понятно.
Easy.
We don't see any questions, though. That means that people understand everything we said.
Может быть, из зала тогда есть вопрос?
Any questions from the audience, maybe?
Есть.
We have some.
А есть микрофон какой-нибудь?
Do we have a microphone?
Робит.
Еще одна минута славы.
Да.
Раз.
Раз. Вы говорили, что AppArmor запускали, получается,
You said that you
он бы
use the complaint mode. Do you think that the enforce mode would help
Повторю, для полноты контекста.
perform that attack?
Профиль для ClickHouse работал в режиме complaint.
Yes, so the ClickHouse profile was in the complaint mode, but had it been in the enforce
Не получилось бы провести.
mode, an RCE
Выполнить команду ID.
would not happen.
Если бы это не было описано в профиле, но это и не было описано в профиле, да. То есть permission denied был бы.
Permission denied.
Спасибо.
Thank you.
Еще вопросы?
Any other questions?
А где микрофон?
Господа, Telegram-бот сломался, так что подходите сюда к сцене и задавайте ваши
The
вопросы.
Telegram bot is broken, so you're welcome to ask your questions live here.
Будет открытый микрофон.
Спасибо за доклад.
Thank you for your presentation.
SE, Linux или какие-то альтернативы?
Why this one? Why not SE Linux or something like that? Or other solutions?
Принято было довольно давно.
Well, we made this decision quite a while ago.
Контекст
I
показался более простым.
don't remember the full context, but we thought it was a simpler solution.
Которые не являются инженерами безопасности, а разработчики могут
The
выполнять этот AppArmor профиль. Потому что
developers who are not security developers can add things to that profile. That's quite a commonly used framework, so we used it for the simple reason of making it accessible to others. Thank you for the presentation. It's an exciting story, but I haven't heard an answer to an important question. How much time does it take from
По реагированию я могу сказать, что в целом мы уложились
finding to patching? Well, in terms of this time, we were within our SLA in terms of finding it. In terms of patching, well, it took us a couple of hours. It took us a couple of hours from the moment we received the alert.
Другая сторона.
Да, спасибо за доклад.
Thank you for your presentation.
На секреты, которые
I have a question.
в сервисах, потому что слайда.
Do you have hunts for secrets that sit in managed services?
До файлика с секретом, но есть ли у вас ханты именно на чтение? Потому
Do
что
you have
смогли прочитать
hunts for reading? Because that would distinguish between
смогли ли прочитать данные из файла?
able, not able to read from a file. We have them, but not for everything. We only do them on a needs basis.
А еще один такой вопрос, скорее про процессы. Вот у вас там были...
A more process-related question. Okay, you've identified the vulnerability and you patch it. Do you patch only for a given vulnerability, or you look broadly? You say that okay, we have a database in the cloud.
Вот вы подсвечиваете как-то своим как бы команде, которая готовит все это дело,
Do you
там нужно больше
highlight it to your team
не только закрыть уязвимость,
that more hardening is required, not just to patch that particular vulnerability, but to see broader? Do you mean to ask whether we have done any lessons learned, that we have patched the vulnerability? Do we, or have we done any looking around? Yes, we have done that. We have looked at where similar problems could be and took a closer look at it.
Еще вопросы будут?
Any further questions?
Какой вопрос вам больше всего понравился?
Which question did you like most?
Мне понравился про секреты. Он очень каверзный.
I like the question about the secrets. That was quite a tricky one.
Починили бота.
А я думал уходить. А почему в клауд-инсталляции ПТ AppArmor не заблокирован shell в enforced режиме?
Why the shell is not blocked in the enforced mode in the cloud installation?
Когда вы пишете AppArmor профиль для
Well,
код-приложения,
you write an AppArmor profile.
соответствует какому-то процессу, этот процесс может вызывать...
This profile addresses a particular application, some process, and all of that is described in the profile.
Описывает
To the extent I understood the question,
код-профиль ClickHouse, который...
it's about a ClickHouse profile that could be launched in an enforced mode and thus to block the vulnerability. It's a good idea and we're trying to implement it. I hope I understood the question correctly. That was a good one.
Будет ли возможность кастомизации алертов Audit Trail?
Will there be a possibility to customize alerts and the audit trail?
На слайде представлены алерты, которые...
Well, the slide
Поэтому
provides alerts that we wrote ourselves, so you're welcome to write your own alerts.
какие-то дополнительные события.
In terms of if any other events are required, you're welcome to approach us.
Допустим, мы передадим эту команду в Audit Trail.
We'll pass it on to the audit trail team.
Новые ивенты для того, чтобы детектить какие-то...
But also, based on our experience, we keep raising new events to detect new things. Why didn't the researchers do reverse shell and try to get access to file .ok? I guess that's a question to the researchers.
Погоди, еще раз прочитаю. Ну, в целом они пытались повысить права, но
They tried to escalate
найти способ
the privileges, but they were not able to escalate all the way to the root.
команды исполняется от имени пользователя ClickHouse.
So the commands were executed on behalf of the ClickHouse user. They were not able to escalate any further. And the final question, why don't you parse with CM, but use an intermediary layer? Well, that's a good question. Previously, it was not possible to do that. And secondly, we don't want to send all events to CM. We only want to send the events for which we do alerts to send to CM, and other events to be sent to other repositories. Or if you have several installations of anything, you want to do parallel threads, and for that we need that intermediary layer.